So, welcome to our mineral masterclass. Obviously, you can see my favourite mineral there at the top, lawsonite, of course. That's a high pressure metamorphic mineral, but you can find out more about that if you want. I'm here to give you the basic key points first, and then we'll have a look at an exam question. Once we've done that, it's up to you then to have a go at those questions and see how you get on with the mark scheme. So first off, you'll see Mohs hardness scale here on the right hand side, and the different hardness tests that you can do. So minerals is all about testing, all about characteristics and things like that. So first key point you'll see is a mineral data sheet. We know that we are going to have that in the exam, and that's going to be absolutely key to our success. Here's one I prepared earlier, and you can clearly see all the special wonderful things that are on there. So the keywords, the key minerals that you need are all on that sheet. So be really familiar with it. Print one off, stick it on your mirror at home or whatever. So you see it every day. The second point is Mohs hardness. Sorry, I've gone one ahead, but it doesn't really matter. The Mohs hardness is all about these wonderful pieces of equipment. In one of your exams, you will be asked to use these and test them, but you should also know how to do each test, because you could be asked to describe that. And very simple scratch test, right? Okay, well that doesn't scratch it. So if we were to look at the Mohs hardness in here, you're going to be looking at something above the 6 area here, because that doesn't scratch it. So each mineral though, whichever one it is, here's one for example, has at least two distinguishing features, and in this case you can clearly see that there's some perfect, beautiful cleavage there, and also the colour. If you look very closely, it is a metallic or more of a vitreous luster, and very, very dark. So this one is clearly one that you've all seen before, and it's biotite, and there's the brown colour, the cleavage. We can also we can do the scratch test on this one. That scratches it, that's a nail, and this should scratch it, which it does. So that tells you that it's this sort of hardness in here. If we look at our mineral data sheet, you'll see that biotite mica has a hardness of 2.5 to 3. So although we're looking at 2, there are other distinguishing features as well for that one. And most minerals usually formed in a particular way, so it's really important to understand the mode of formation as well. That's going to be very, very important. And the example that they've given here is magnetite and gravity settling, because it's associated with igneous processes. There are others like the hydrothermal fluids, which precipitate in mineral veins, and that's going to be really, really important. So there's some keywords there that you really should be using. This one, precipitation, and the hydrothermal, which of course means hot water. And the metals, of course, are going to be very common. So galena, which is the ore of lead, commonly forms in this sort of environment. So lots of minerals become concentrated due to their properties. And while I'm on the subject of quartz, these are all quartz. Yeah, you can clearly see that they are distinctly different. They have different colours, so you cannot use colour as just a diagnostic property. But we can use acid on here. I haven't brought some over, but we could put some acid on that, and that will not react. And that is one of the reasons why it can be found in sandstones like orthoquartzite in a shallow marine beach environment, and that's going to be really, really useful, because that gives us an idea the rock type associated with the minerals and the type of question that they might ask about that. Quartz, obviously, we can test hardness on that as well. So that's the basic mineral masterclass. Got one final bit, which is our tip, which is up here on the top right hand corner, and I'll try to do one of these for each masterclass. I'm trying to talk quickly because I don't want to bore you too much, but each of the characteristic tests, you must understand, you must be able to describe it and say how you do it and why you do it. Density, Eureka can, you know, all those things that you should know. So look back at your lab books for those things. So welcome to the exam skills part of the Minerals Masterclass, and you can clearly see at the top there is a bit of help with regards to, you know, I suppose a tip. They reuse diagrams, reuse questions, do lots of practice. So go away after you've done this and find some other questions based on minerals that you can have a go at, or ask me and I will give you some. So before we start, I will be looking at figure 1A over here and figure 1D over here, and looking at what is the nature of the data that I am being asked to, you know, analyze or interpret or whatever. And the nature is that this is a map on the right hand side here, so you know we can clearly see that there is a map involved, and on this side over here it's a specimen. So it's from our own point of view, and you know we've got a nice scale on the bottom as well, which we're looking at over here, which can help us, and this one's got a scale as well, which is always important. But this one over here, figure 1A, is a map view, so we are looking down on that particular bit, and I would be encouraged to look at as much information as possible. So we can clearly see that, you know, mineral F is associated with this particular piece of information up here, and it says about the igneous rock, which is on this particular one, and it's collected at location B. So we're looking at this area here. Something else which is relevant at this point is that there is a variation. It's saying there's a variation in crystal size, which is occurring, and that's from, you know, A to B, as you would expect, because this is an intrusion. And also we've got our metamorphic aureole, which has been identified on there as well. So we've got our limit of metamorphism, we've got our igneous body there as well, and we've got another key term there to make sure we know what that is. There's an orthoquartzite. So that's metamorphism, which is happening in that particular area. So we can clearly, you know, identify the key aspects in there. Now we're going to use our mineral data sheet, of course, but there's some plagioclase feldspar in here. We know this is an intrusion because it says it up here. We know it's a specimen associated with an intrusion because it's also on the map here in this location somewhere, or B here. Also, mineral F has two good cleavages and it's dark green. Look, it tells us. So that narrows it right down. If you haven't guessed what it is yet, have a look on the mineral data sheet. It's still here. The other thing is they're asking for three terms which describe the igneous rock shown. Now, before we go any further, you know, one of the things is composition. The second thing is, you know, come back to this scale here, because actually it's really, really important. I was trying to draw an arrow and that's terrible. There we go. That scale there is going to be very important, because each of these areas of minerals and these crystals are going to be significant. Most of those patches, and they're not, it's quite hard to see some of the crystals in there, but you can clearly see dark and light patches. Some are quite small, these little ones here, but most of them are sort of 3 millimeters and plus. yeah, in size at least. So that should tell you, well, what sort of, igneous rock is it? So it should help you with that bit. Back to this question here, it's not foliated. That's a metamorphic term. So we've narrowed it down straight away. We've got these ones here that we can pick from. If you're looking at plagioclase feldspar, we've got a dark green mineral there. So I'd be thinking this one's very, very likely to be mafic, isn't it? And not silicic. Now you can do the others, and I would encourage you to mark it then afterwards. We'll go on to the next question in a minute. So on to the second part of this question. You can see we've still got the figure 1A over here, and we've got the variation in crystal size. We know that. We've got some other localities. So we've got C over here, which is going to be very, very relevant because it says location C over here on this question, and also D. So D, and the difference between D and C, clearly, one is outside that metamorphic aureole and one is inside. That's the aureole there, between there and there, and this is laying outside. So it's not within the limit of metamorphism, which is that bit there. So it says complete figure 1E showing the texture, yeah, of the sample of metaquartzite. So in here, in this lovely provided section, we are going to be drawing a metaquartzite, okay? And they've given you a 1.5 millimeter scale. They've given you a scale here. So what does a metaquartzite look like? Well, think about it. It's a metamorphic. It's going to have undergone key things like recrystallization. So what's that going to look like? Have a go at drawing it. Have a look on the mark scheme, see if you satisfy it. It's worth 3 marks. So 3 key things to show the texture. So you're going to be looking at the size, which I just mentioned. What is the key mineral that you're looking at there, and what's the overall structure of the diagram going to look like? And remember, it's a scientific drawing, so be accurate. It's like what we've done in our lab books. The second part here, compare the mineral composition and texture of the rocks. So we're looking at mineral composition and texture. It's worth 4 marks, 2 marks each. It says explain your answers. So you need to justify your choice. So make sure you mention location D has this, location C has this. Okay, it's really important that you mention both. There's so many people make the mistake of saying, oh, location C has this, but then they don't talk about the other location. That's the biggest mistake that people make. So location C within the metamorphic aureole, so you'd expect the mineral composition to be the same, different. What's going on? What do we know about metamorphism? I'll give you one word of help: isochemical. Make sure you know what that means. Texture, of course, is definitely going to change. We're not sure about mineral composition. Is that going to change? I'm not sure. Texture is definitely going to change. It's going to recrystallize. Over here, this is sedimentary. Yeah? So it's going to have a distinctive sedimentary texture. All right? Have a go. See what you think. When we're talking about sedimentary textures, remember we're talking about grains. When we're talking about metamorphism, we're talking about, well, recrystallization. So we're talking about crystals. Hopefully that helps a little bit. Have a go at those questions. Mark them using the mark scheme on the next slide, and go and have a go at some more once you've done a bit more revision if needed. Hope that helps. Over and out.